We are live, sir.
Okay. Hello, friends. This is Mr. Sarvesh Marzurkar. We are now looking into the matter for the fifth lecture of AICT sponsored Prerna scheme for SC/ST candidates for Ballarpur Institute of Technology. In this today's video, I'm going to explain you about as we were in that programming and data structure subject, where the topic we have covered yesterday is like arrays. And in today's class, we are array stacks and queue. We have covered it yesterday. And in today's video, I'm going to explain you about the linked list and various types of linked list. What are the various operations on linked list that we are again going to cover it in today's video. First is, what is a linked list? As the name suggests, linked list. It is a simple type of data structure, or we can say it as a linear type of data structure which can change during the execution, where successive elements are connected by pointers. There is a link between the two different nodes or two different elements to denote what is there and what is the relation between them. From where, from which node you have to go to which node, that is being denoted with the help of a link. That's why it is called as a linked list. Of course, the last element does not going to any different element. That's why the last element or last element points is to be set it as a null. It can grow or shrink in size during execution of the program. It means we can add any element into the linked list. We can remove any element from the linked list. It can be made just as long as required unless and until we are providing the addresses to the linked list into the linked list of all the elements. It can go on and on. It does not waste memory space as well. This is the small example of linked list, how the linked list can be there in a particular data structure where A, B, and C, three different elements are there. Firstly, A is having the node A is divided into two different parts. One is a value and another one is the reference, where A is nothing but a value, and the part which is there with the help of a dot, we can say that it is a address of the next location or reference of the next location, where A is having the reference of notation of the next element, that is B. B is having the reference of next element, that is C, and C does not having any notation, any reference of the another element. That's why we'll call it as C is the last element of this linked list. C goes to null itself. Likewise, head is the A and tail is the C. Keeping track of linked list is like it must know the pointer of the first element of the list, where it is called as start or head, etc. Or start node, beginning node, we can also say it like this. Linked list provide flexibility in allowing the items that need to be arranged efficiently. We can perform two different operations on linked list, that is insertion of a new element into the linked list and delete an element which is already there in the linked list. Next slide is about the illustration and insertion in the linked list. If For example, if I want to this is a given linked list, for example, say A, B, and C. And in that linked list, if I want to insert a new element, that is say X, that is a temporary element, into the linked list, it can be added in between A and B. Ultimately, I have to change the location which is with A. That location I need to change. That earlier it is with B. Now I am going to insert a new element in between A and B. It directly means that I have to change the location of A, which is A is having. It means we have to change the location of A. Like A earlier it is with B. Now I am going to change it with X. So definitely current A, now it is changed to X, and X is carrying the address. X is carrying the address of the next element, that means B. So likewise A to X, and X is having the address of of the earlier element, that is B, and the string and the element insertion is like this. This is a simple illustration of a linked list. The pseudocode for insertion is like a simple way. Why we have to add a new element into the linked list where the size we have to already identify along with the malloc. That is the size of a node. Temporary is equal to the next current is greater than, sorry, current is greater than next, of course, and then we can change the address of the next location. Same thing we can do it with the delete also. For example, if I want to delete a element B from the linked list, again I need to change two different addresses. Firstly, the address of A should be get changed and B should be get changed. The address which is already with B should be shift with A, because the element we are deleting, that is B, is having the address of the next location, that is C. So the next location C, the address of that next location C should be with A, because we are removing the node B from the given linked list. It's like this current, and this is the temporary. It is B. B need to be changed. Ultimately, the address of A should directly go with the address of C. The address of A should be changed. It should be shifted to C itself, like this. Pseudocode for deletion is like simple. The exact contrast in terms of addition, we need to change the address of the locations. In essence, for insertion and deletion, I have one small note to you guys. A record is created holding the new element, and the next pointer of the new record is set to link it to the atom, which is to follow it with the list. Next pointer always carries an address of the previous location so that it can point to the next element in the linked list. The next pointer of the item, which is to be which is to be precede, it must be modified to the point to any new element which we are going to insert it. For which we are going to insert it. Next is for deletion. There is one simple step I can say. The next pointer at the current item, the next pointer of the item immediately preceding to the next, and and if the element is to be deleted, which is altered and made a point to the atom which is following deleted atom, which is following to the deleted atom, I can say like this. Next one is array versus linked list. Question arises, what yesterday we have gone through the array part, and now we can check the difference between the array and the linked list. There are three major differences, I can say. First is inserting and deleting an element at the end in arrays, whereas randomly accessing any element in array, we can randomly access any element in array, but in linked list we are unable to access any element unless and until we have the address of each location with it. Then searching the list for a particular value is again possible in arrays, but in linked list it is not possible. In terms of linked list, we are having the following advantages, that is insertion of a new element, deleting of an element which is already been there, and applications where sequential access is required. In situation where the number of elements cannot be predicted beforehand, so it is quite possible for us to go with the situation where the number of elements cannot be predicted beforehand. We have to go with the help of link itself, we have to work with the help of link itself, and accordingly we have to move forward in that particular manner. Next one is various different types of linked list and what are the various operations on linked list. That is really a major concern. First of all, we'll go with the types of linked list, where depending on the way in which the links are used to maintain the adjacency, several different types of linked list are possible. Firstly, we can go with the singly linked list, that is linear singly linked list or simple linear list, where one we have discussed so far, nothing but the same which we have up till now, we have discussed it, circular linked list. The pointer from the last element in the list point, as we know, we can simply consider this particular diagram. I can explain you with the help of this particular diagram how the circular linked list will be. Say, for example, A, B, and C are the three different linked lists, three different elements in the given linked list, where A is carrying the address of B, B is carrying the address of C, and C is carrying the address of null. Apart from the address of C, which is carrying it, which is in null, we have to change that address. We have to change that address, and it should be of the first node, that is A. It should be of the first node, that is A. If we are going to change the address of C from null to the address of A, ultimately the last node can point it towards the first node, and this is nothing but the circular linked list, exactly like this. Exactly like this. Say A is having the address of B, B is having the address of C, and C is having the address of, say, A. Apart from null, we are shifted it to A. Ultimately, this whole diagram is called as this whole process is called as circular linked list. Doubly linked list. What is doubly linked list? Doubly linked list is a pointer that exists between adjacent nodes in both directions. Pointer exists between adjacent nodes in both direction, so it is a two-directional linked list as well. This list can be traversed either with the forward way or with the backward way, because the addressing of the nodes or the links, we can address it in both ways. It may be towards right, it may be towards left as well. This list can be traversed in either forward or in backward direction. Usually two pointers are maintained to keep track of the list, which is head and tail, like this, where I can directly say that A can go to the left as well, or A can go to the right as well, because it is having the address of both the different way, and it is divided into three different parts, where the left side of the element carries the address of the left of the previous node, and right side is carrying the address of the next node, and vice versa, I can say like this. Usually two pointers are maintained to keep the track, that is head and tail. Now the question for which we are going to study the linked list is like basic operations on the linked list. What are the basic operations on the linked list? First one is creating the list. Second one is traversing the list. Third one is inserting an element in the list. Fourth one is deleting an element from the list. Concatenating two lists in one. It means merge two lists in one. These are the basic operations that we are going to perform it on the link in the linked list. There may be a question in GATE examination is like concatenating of two lists is possible in linked list. True or false? Simply the answer is very true. List is an simple abstract data type. What is an abstract data type? As if we have already studied it in programming language C, where abstract data types are which is already defined by the user. Typically, for more complex than simple data types like integer, float, etc., we have already defined it in our way. Why abstract? The question arises, why abstract? Answer is very simple, because details of the implementation are hidden. When you do some operation on the list, say insert an element, you can just call the function. It means you are going to give the reference of that function so that you may call it. Earlier it was hidden. before implementation, all are hidden. Details of how the list is implemented and how the insert function is written is no longer required. That's why the abstract is required. Basically, the conceptual data. Say, for example, any conceptual data is given to you. You can able to insert, delete, and traverse. Traverse means to roam. To visit any element into the list is called as traversing. We'll definitely see it in the trees in the upcoming lecture. In the next lecture, I'm going to explain you about various ways of traversing into the tree with in order, pre order, and post order type of the things that will help you to get the concept about this. We can insert the element into the list, we can delete the element from the list implementation and related function and the related functions are possible over here. Next is this is a simple example where we can work with the linked list. Consider a structure of nodes which is as follows, that is struct student, integer role, character name, integer age, say character name is 25, integer age, and struct student, that is the next one. A user defined called data type called as a node. We can expect it the output like this, and type the difference between the structure and the student node, where node is star head. We can able to give the address of the next node where we want to go with with that particular value. Simply creating a list, that is the question. In when we, as if we are doing this, we are studying this data structure with reference to C or data structure through C. To start to start with, we have to create the node, that is the first node, and to make the head point to it. For example, head is equal to the node start, to create the node and to make the head point to it. To make the head point to it. Next is malloc, that is the size of the node which we have to identify. For example, like this, head is equal to roll number, or we can say it as roll, then name, and then age. And then the next part comes into the play, that is next, where the next carries the address of the next location. Next carries the address of the next location. We are go with this with front element, that is we are going to call it as a head node. We can allocate, if there are n number of nodes in the initial linked list, allocate n records one by one, where we can read in the fields of the record that can modify the link of the record so that the chain is formed. And this is simply like this: A is carrying the address of the next location, that is B is carrying the address of the next location, that is C, and C is carrying the address of the last location, that is none, in singly linked list. Same thing. This is the proper syntax for the same. Next is traversing in the linked list or traversing in the list. How the traversing is the another operation that we can able to perform it in the linked list, which we can explain it with the help of once the linked list has been constructed, and head points to able to of the nodes as they are traversed, the next pointer points to none. That means the end of the linked list. These three are the main we can say that rules while traversing it into the linked list. White display node, that is head. This is the this is the proper or typical syntax where what we have to denote at the beginning, that is count is equal to 1, p is equal to head, p point towards not equal to null. Of course, the first element will not be the null, and then printf next along with a roll number, name, and age. Your sequence should be like roll number, name, and age, and then the pointer point towards the next element. Now, inserting a node in a list. How to do it? The problem is to insert a node before a specified node, where we can specified means some value is given for the node called as key. In this example, we consider that it is to be a rule, because we have already gone through that particular topic where roll number is given first, then the name and the age of that student. Then convention is followed by how to follow the convention. If the value of the roll is given as negative, the node will be inserted at the end of the list. This is normal the convention which is followed. Then when a node is added at the beginning, only the next pointer needs to be modified. Only the next pointer needs to be modified. Head is one more instruction is like head is made towards the point. Head is made towards the point of the new node, where the new node points to the previously first element. With the help of instruction, with the help of insertion, I have already explained it to you how that insertion of a node at the beginning of the linked list is possible. When the node is added at the last, I mean at the end of the linked list, two next pointers need to be modified, the previous one and the next one. Last node, that is the new point to be the new node, and new node point to be the null, because that new address goes to the new element and the null address goes to the new element which we have inserted at the last or at the end of the given linked list. When a node is added at the middle, again two next pointers need to be modified, the address of the previous one, that is previous node, and new node points to the next node. That's it. These three different steps, and sorry, these three different cases, we can definitely able to add the new node at the beginning, add the new node at the end, and add the new node at anywhere in the linked list, or we can say it as at the middle of the linked list. This is the simple pseudo code for that given uh, linked list operation. The pointers Q and P always point to the consecutive nodes, and to be the main function, to be called from main function, the node head should insert a head node. Deleting, of course, we can, if we are able to insert a new node into the linked list, we can say that we can definitely delete the node from the linked list as well. We can delete the node from the linked list as well, again, again in various different position. How to delete the node? First of all, we can say what is to be done. Here we are also required to delete a specified node. Say the node whose role field is already given. Here also three different conditions arises as they were arises at the time of insertion of new node. Similarly, when we are going to delete the node from the list, again there may be the three different conditions that can arises, and that conditions are as follows: deleting the first node from the given linked list, deleting the last node from the list, and deleting the intermediate node means a node except the start node, except the first node and the last node. Whatever the node which is there present and in between the link, in between the first node and last node, that is uh, from the start and the end, called as intermediate node. There may be a question in this case: which of the condition is suitable while deleting a node from the linked list? Deleting a first node, deleting a last node, deleting an intermediate node, none of this. The answer is all of this. The answer is all of this. You can simply say answer is All of this, all can be the things where we can perform the operation called as deletion of a node from the linked list, which is at the first node, which is possible at the last node, and which is again possible at any intermediate node from the link of the linked list. Next is this is the proper pseudocode for the same, where delete node, that means head node, we have to delete it first, and then this is the proper pseudocode. If you go through it properly, deletion failed may occur as well. For the reference and to be get expertise in this particular manner, I can say I can give you a one small exercise to try it out, where write a function to concatenate two given list into a big list. You need to note down the function to concatenate the two given list into a big list. Answer is very simple. Node star concatenate, node star head 1, node star head 2. That's it. Whatever the head 1, we have to denote it with head 1, and another one we have to denote it with head 2. And before that bracket, we have to put the operation which function you need to add, that means concatenate or insert or delete or whatever. First is we can concatenate over there. Next is insert an element in the linked list in a sorted order. That is a big question. How to do the element in a sorted order? The function will be called for every element to be inserted. Function which is to be called for every single element which is inserted in the linked list, and you need to rectify it with the help of one function, named it as like this: void insert sorted node bracket node, that is star star head comma node star element, where we have to arrange it in a sorted manner. Of course, it is in ascending order, it is in descending order, it is in any of the order. We can able to sort a node in the linked list by applying this condition and by applying this function. Next is always insert elements at one end and delete elements from the other end, called as first in first out. Simply you are following the application of queue, where we can insert it from the rear end and remove the element from the front end, where void insert queue, that is node head and node element. Node delete queue, node star star head, that return to the delete node. Of course, that returns to the delete node which is already there, like this. First in first out, that I have just now explained it to you how it works. For example, if I want to insert two or three different elements into this queue, the first element is to be inserted in this queue is like, for example, say A. We have added a queue. A is entering in the queue. If the element A is entering in the queue first, definitely it will exit first, like this. Then we have already the element which we are going to insert afterwards after A, that is B, and at last we are going to insert C. The same sequence will be get out from the queue. First is A, and then second one is B, and the third one is will be C, like this. Last in first out. Sorry, so this is all about the structure of queue, which is followed by the queue, the principle of first in first out. The elements which are inserted in the linked list is like this: A, B, and C. Firstly, A is enters in the queue and get out. B is enters into the queue, gets out. C is enters and then gets out. This is also called as queue, first in, first out. Next is in contrast with that, the last in, last out. Sorry, the last in, first out. The element which is inserted last should exist first. Principle of stack. The element which insert first should exit at last, or the element which is enters last should exist first, should exit first. Last in, first out, or first in, last out is called as a stack. For example, if I insert the element A in this stack, it enters first, then B, then C. After that, if I want to remove the element from this stack, the first element which is out, it will be C, because it enters at last in the stack. First is C may get out of the stack, from the stack, and then B may get out from the stack. After that, you can able to get out the element A from the stack. Ultimately, I can say that the element which is inserted first will exit last, or the element which inserted at last should exist first. It is last in, first out. This is also called as the stack as well. Then we'll go with the abstract data types. One is complex number, where float, float 3, float IM can be there. And this is a simple structure definition for the same, say, for complex number. As we know that we can add, subtract, multiplication, multiply, and divide the number called as any number, we can say. The simple definition of complex number is like it is a number that can be expressed in the form of a plus bi, where a and b are real number and one word is imaginary number. That's why at the beginning of this syntax or of this pseudocode, firstly I have mentioned float re, that re stands for real number, and float im, that im stands for imaginary number. We can perform the various operation on that. It is a symbol called as imaginary unit, and that satisfy the equation, say I square is equal to -1, because no real number satisfies this equation. That's why we need to carry one imaginary number. Along with that, by applying that imaginary number, we can able to perform operations on complex numbers as well. We can definitely able to perform the following operation, that is addition, subtraction, division, then multiplication. We can read it out the elements, we can print out the elements as well in the given in the given list of elements. Then another example I need to put in over here, like set manipulation. We can definitely perform it with the help of linked list, where struct node we need to define at the start, it is integer element, struct node that we need to define at next, and there should be a set. For example, set theory, we can do the union, intersection, again minus, insert, delete, size of the set, we can definitely able to solve. It is simply the mathematical notation that set involves no duplication over there, so that we can so that if we have a series containing 4 elements, say a b c and d, the set is to be formed like this: AA, AB, AC, and so on and so forth. There are many different permutation combination that can be performed with the help of this set theory. Next is we can again able to perform various different operations on set theory, that is union, intersection, it means again addition, intersection, minus, that is deletion or subtraction, I can say, insertion and deletion again can be performed on the set theory. Same thing on the stack, we can perform two different operations, that is push, sorry, this various three, five different operation. One is push, another is pop, then create. We can able to create the new stack. We can also able to remove all the elements from the stack, that is pop. It can again perform the various operations like stack is empty and stack is full. That stack is empty and stack is full, it means if there are no any elements to remove from the stack, ultimately we'll say that the stack is empty. And next one is if there are no any space required to add any different element into the stack, you can say that the stack is already full. This is all about the abstract data type. Again, I can say that it can be continued in next slides like this. We shall look into two different ways of implementing the stack. One, we have did it in the last class, that is last video, that is arrays. Using arrays, we can implement it the stack in the last video. And in this video, we are going to see it with using linked list. First, we'll go with the array again. For example, say this is a given stack of two different elements to you, where the first element I'm going to insert at the top of the stack. If like this, I am going to insert the color orange in the stack to insert a new element into the stack like this. If I want to remove the element from the stack, I can definitely perform the pop operation. Can definitely perform the pop operation. Now the top is incremented by 1. If I want to remove that particular element from the stack, I again need to, the value of the top may get changed. It should be get shifted towards the downwards, and the value of the top will be at the, it may change the value over there like this. Now, the top is that, no, it is not in that position. The top is again comes to downward, that is at the beginning of the stack. This is all about the way which we have seen it in the last video which I have explained about arrays over there. Now, in this, with respect to the linked list structure, the whole structure is like this. So the top is always at the beginning of the list. It means at the start of the linked list. If we want to perform a push operation, that means insertion of a new element in the linked list, in the given linked list, I can perform the insertion operation over there. Can perform the insertion operation over there. That insertion operation is simply like the adding new element into the list. For example, if I want to insert it at the beginning of the linked list, it should be seems like this. At top, previously the top was like this. Top was pointing towards this first element, and if I want to insert the new element into the linked list, the value and the position of the top need to be changed. Top should point towards the new element which we are going to insert like this. If I have insert this element, the top should point towards the new element like this. And then that particular element should carry the address of the previous element, that is the very first element, and ultimately we have inserted a new element into the stack. Again, if we are going to perform the pop operation, initially the top is at the very beginning, that means the first element. Afterwards, if I want to remove that element from the stack, that means the first, ultimately the position of the top may get shifted to the next element like this. Previously it is with the very first element. I can say that an element named as A, and And the rest other elements are B, C, D, E, for example, for our consideration. And if I want to remove the element from the top of the stack, ultimately the value of the top will be get changed. The position of the top will again get changed like this. The value of the top will get shifted to the next element. Ultimately, we have deleted the first, that is, we have deleted the top element, we have deleted or we have performed the pop operation in the linked list data structure. How this idea comes into the play? In the array implementation, we can declare the array of fixed size, we can which determines the maximum size of the stack. We can able to keep a variable which always points to the top of the stack, where the top of the stack may get change top of the stack may get changed according to your operations. If you are inserting the element into the stack, definitely the top may get increases. If you are deleting the node from the stack, definitely the value of the position of the top may get decreases towards the downwards element. Next is keep a variable which always points to the top of the stack that contains the array index of the top element. Array index of the top element. Next is like in the linked list implementation, we would, these are the few points, which is the idea behind it is just told. Okay. Uh, in the linked list, in the linked list implementation, we would maintain the stack as a linked list. We can able to pointer a variable top that points to the start of the list. We can again, it is again possible for us to the first element in the linked list is considered as the stack top or top of the stack. This is declaration. Simply the simple pseudocode that I have mentioned over here is like this for array. It is for the maximum size in structure size, that is maximum integer at the top, where it denotes the top of the stack. And same thing in linked list stack struct LIFO, where integer value struct LIFO, that is the next, and type def struct LIFO stack, where the position of the stack get changed to the next element over there. How to create the stack? Stack can be created by using two different ways, that is array and linked list as well, where array can be used it with the help of this particular pseudocode, where void creates, if we want to create a stack, that is s, if we want to create a stack, that is s, so s should be at the top, that is equal to -1, and s top points to the last element which push in, and that means push means again to add or to insert a new element into the stack, and initially it is -1. So this is the pseudocode for array. And the pseudocode for the linked list is on the right side of the screen, where void create we can stack the top, and the top is equal to null. So top points to null, indicating empty stack unless and until it is empty. Yes. The question then arises how to check that stack is empty or stack is non-empty. Firstly, for array, it is having the pseudocode is like this. Majority, the reason for which I am going to show this pseudocode, majority of the times the question asked in GATE exam that this pseudocode is given to you, and is it clear? Is it for which type of status this pseudocode applies for? For checking the for stack is empty in array, for checking the stack is empty in linked list, for checking the stack is full in linked list, and for checking the stack is which is empty in array. In oh sorry, full in array. Likewise, a given pseudocode is given to you, a normal pseudocode is given to you. You need to check it out and write out and pick out the perfect answer. That's why this pseudocode is very essential for you to mug up and to go through it in a normal way, just for such type, just to be ready for such type of questions in the gate examination. Same thing as if we have already done it for the empty stack. The normal pseudocode for the checking for the stack is full in array, as well as if it is full in linked list is given over here. You can go with that. For example, in terms of if the stack is full in linked list, there should not be any, we will not required for linked list implementation. In the push function, we can check the return value of the malloc. If -1, then memory cannot be allocated. If it is +1, then and only then the memory can be allocated in linked list. Next, queue implementation in linked list. Very interested and much more interested topic, where queue implementation in by using linked list. For example, how to implement a queue using linked list. Up till now, we have already studied about implementation, stack implementation using linked list, and now we are going to implement the queue in the linked list. What is the basic idea behind it is, we can create a linked list to which elements would be added to the one end and deleted it from the other. Queue follows first in, first out type of property, where the element which is inserted at the beginning of the linked list, beginning of the queue, should be exit first from the queue. This we can create a linked list in which two items, as I have already mentioned, that is element from one end, added from one end and removed and deleted from the other end, removed or deleted from the other end. The two pointers will be maintained is like this: front end and rear one, I can say. One pointing towards the beginning of the linked list, that points from where the elements will be deleted. And another one is rear, where the element can be inserted. Another point to the end of the list, which is located in the linked list, where we are going to apply it for the queue. Again, there are two different ends: first front end and rear end. I again repeat, one pointing to the beginning of the linked list, that means point from where the elements will be deleted, and another one is points from the another pointing at the end of the list, where the point that points where the new element can be inserted. These two operations we can able to perform, that means insertion as well as deletion from the given linked list, by applying the principle of queue, that is the element which is inserted first should exist first, and the element which is inserted at last should exist last. Then queue as a linked list structure. This is simply like this: from front end we can able to insert the element, from delete the element, and from rear end we can able to delete the element, insert element, uh, enqueue is the name of the operation where we can add a new element in the linked list. If we are adding any new element in the linked list, it is called as enqueue. Like this, insertion takes place from rear end and deletion takes place at front end, where if previously the rear end is having the address null, there were only 5 different elements present in the given linked list. But if we want to add one more element at the rear end of the linked list, definitely the address of the last node may get shifted from null to the address of next node, which we are inserting at the end of the linked list. Ultimately, that address may get shifted and changed to the next node like this, so that we can change the location of the rear as well, where the rear previously it was with this fifth element, now it will be go with the new element, new inserted element, that is the sixth one, like this. Now your rear is the sixth element. Ultimately, we have performed the operation of enqueue in the linked list. That means we have already added one new element into the linked list. Definitely, if it is possible for us to insert a new element into the linked list, it is 100% possible for us to delete the node from the linked list as well. Where how can it perform? That deletion of the node from the linked list is very simple, as exactly like this of insertion. Only difference it means we have to remove it, sorry, we have to delete the uh, uh, node from the linked list as at from the front end. So the value of front may get, the position of front may get changed. First is like this. If five different elements are there, we have to perform the delete operation, that is dequeue. Ultimately, dequeue can be performed it like this, to remove the element which is already located at the front of the linked list. Ultimately, I have deleted that element, and the position of front may get shifted to the new element like this, the second element like this. Previously, there were five different elements, now there are only four. This is the simple pseudo queue using the linked list. So normal C program I can say stdio.h, library.h, and string.h. Where struct node is equal to the character name 30, character node says next, and it can type the struct node q node, and along with that, this is the normal pseudocode for the same. Front can be pointed towards the rear, rear can be pointed towards the front, then the thing is called as the circular linked list. Likewise, problem, there should be certain problem that may arises at the time of array implementation. How that problems it would be? The problems are, uh, see, if the linked list of the size say 0 to n, front end is on the left hand side and rear end is at the right, at the fifth position, definitely that rear can be changed if we want to perform the addition, because we are performing the addition from the rear end. Previously, the values are 4, and the fourth position is having the location of rear element, fourth position. And now, if I want to add any different element at the rear end of the linked list, it is possible like this. The value of, sorry, the position of the rear may get shifted to another position. Previously, it was with this. Now, if I have inserted new element, the position of rear may get changed like this. Now there are five different elements. Previously there were four, and the rear position is having with the fourth element. And now if I have inserted one more element, the rear position may get shifted to the other one, that is fifth one. Same thing if I want to perform the delete operation. This is enqueue. This is all processes of enqueue. If I want to dequeue the operation, if I want to perform the dequeue operation, the position of the front may get changed, because the deletion operation we are performing in the queue is will be at the front end, and the insertion operation we are performing in the queue is at the rear end. So so while going it with this, the value of the front or the position of the front may get shifted to the previous position, or it is decremented by 1 like this. That is called as DQ. Effective queuing, that means performing this queuing storage area of array, it may get reduces if we are performing the deletion operation. Use of circular array indexing is definitely possible, where a queue, it is an example of an array implementation where define maximum size, say 100, along with the character name, say 30, whatever that thing, we can define it with the help of a particular example. It may vary according to the size of the given linked list. This is the simple example. If q is equal, front is equal to 0, and if both are 0, if front is equal to rear, if front is equal to rear, you can simply say that the queue is empty. If rear is greater than front is equal to 0, ultimately you are having certain scope to add any different element. Full is equal to 0, q is less than equal to empty, that is equal to 1. If q is full, it can show the message return q is full. If q is empty, you can show the message q is empty. So ultimately this can be performed in a queue in a linked list by applying queue as operation. If you want to say that queue is full, we can definitely print q is full if the function f rear size is q is greater than rear plus 1, and front is equal to q which is greater than rear as well. Otherwise empty 0. And if the queue is null, I have already explained it with the example. Next, in the tabular format, I want to explain the difference with you for you guys. It is the difference between the array versus the linked list, where array is nothing but fixed size, where resizing is quite expensive, whereas with respect to linked list, it is quite dynamic size. So resizing is not that much expensive in linked list. Insertion and deletion are inefficient, where elements are usually shifted, and in arrays, where in linked list insertion and deletions are efficient, no shifting takes place because it is having the address of the next location for you. Where in arrays you can access any element randomly, where in linked list we cannot able to access any random element. No memory waste is there in array, and in linked list there is a quite memory. Waste is there since memory is allocated dynamically. So to need so according to your need, there is no wastage of memory. Next is sequential access is faster in arrays, and sequential access is quite slower in linked list. So this is all about the difference between the arrays and the linked list. And now we'll go with the applications of linked list. There are various applications where linked list can be used. It is the major application that we have used it in MRU, that is a linked list of file names, where the cache memory in your browser that allows you to hit the back button. It can undo the functionality in Photoshop or Word or Excel or anywhere else. And a stack hash table in a binary tree can be implemented using a doubly linked list. What are the advantages of linked list? There are various advantages of linked list. I have some pointed out for you people. Only good for non-sparse polynomial, ease of storage and retrieval. Of course, if there are certain advantage, there should be certain disadvantage of linked list as well. It requires some more memory. It have to allocate array size ahead of time. It is having huge array size required for sparse polynomials, as well as wastage of space and the running time is also a major disadvantage. For example, simply this polynomial for doubly linked list, as normal example link representation or link implementation, P1 of x is equal to 23x to the power 9, 18x to the power 7, 41x to the power 6, and so on. The equation is simply like this. Ultimately, the tail and the node, we can able to perform it with the help of array implementation or by using the polynomial representation. Some advantages of using linked list are it saves space, that do not have worry about the sparse polynomial. Except sparse polynomial, it saves the space and it is easy to maintain. Of course, don't need to allocate list size and can declare nodes as and only when needed. Some disadvantages of linked list are also there. It cannot go backwards through the list, and it cannot jump at the beginning from the list to the end. That is the major disadvantage. Except polynomial, there are no any as such disadvantages of this I can say linked list. So I hope the whole concept of linked list is being clear to you, has been clear to you. Thank you very much for your patience hearing. Over to you, sir. Sandeep, sir.
Yes, sir.